When doing chemistry experiments, it's incredibly important to know the formulas of the chemicals you're working with. That way you can look up safety information and make sure that you're able to track what's happening with those cutie pie little atoms. I love this laminated chart. So nice and organized. We've got ingredient number 1 listed at the beginning of the row, ingredient number 2 listed at the heading of the column. And if you just drag your fingers along to the point where they meet, we've got a nice little spot that we can do our reactions. So what I'm going to demonstrate is how to use ingredient aluminum chloride, concentration of 1 molar, mixing it with 4 other types of ingredients to see what happens. We're looking for evidence of chemical reactions. Right now we're studying ionic compounds. So I'm going to distribute 4 drops of the aluminum chloride into each of these little spots. And then I, to stay organized, just kept all of my other ingredients lined up at the top of their columns. So this dropper bottle just has a little rubber plunger. You squeeze it to pull some of that up. This is adding sodium carbonate, adding 4 drops as well. If I accidentally get a little bit extra, it's not a problem, but I'm still trying to be careful. Now I'm adding sodium chloride. With my third substance, sodium hydroxide is a base that could potentially irritate my skin or my eyes. So notice how it has a warning that says, wear your goggles. 1, 2, 3, 4. And then we've got sodium phosphate, Na3PO4. Occasionally the change will be instantaneous. Sometimes it's more of a slow, steady burn. So I'm going to zoom my phone in. Let's take a look at what's going on in these little circles. I see a little bit of action happening in box A and in box D. Box A has definitely got some foaming going on. Nothing too dramatic, but absolutely evidence of a gas forming. So we'll keep an eye on that little guy. All right, now let's look at mixing happening in square B. Nothing too exciting or obvious happening yet. Box C, nothing really apparent. And then box D, ooh, I see a white solid appearing. It's kind of smoky looking, a little swirly, like little clouds. Pretty cool. So let's talk about what's going on. Let's consider the ingredients that resulted in product A. Aluminum chloride and sodium bicarbonate. You would write those on the left side of the equation. And these ions can separate from each other. Aluminum is at the beginning of the ionic formula, so is sodium. Those will be positively charged cations. Chloride and carbonate are both anions. Chloride obviously is just one element, but with carbonate, that's a polyatomic ion because it has more than one element involved. So when these chemical reactions occur, you have this little do-si-do dance, little switcheroo of partners happening. So that aluminum can detach from the chloride and say, hey, I'm going to go hang out with someone else right now. And the chloride's like, all right, bye, see you later. And that aluminum's going to attach to the carbonate. Alternatively, you've got the sodium cleaving away from its previous carbonate partner and hanging out with its good old buddy chloride. So 2 products that are forming. But let's consider what's happening in box B. And I think that you'll have no problem understanding this, but think about this logically. If aluminum chloride is one of your ingredients, and the other ingredient is really similar in formula, sodium chloride, they have the same exact anion. So even if the 2 components of the compound detach and they switch, it's going to result in the same thing. Because you still have to balance your charges. You still have the rule of zero charge that you need to obey. So it's not going to form anything new that's impressive. In box C, sodium can detach from hydroxide and go with the chloride from this ingredient. Aluminum can detach and attach to the hydroxide polyatomic anion. We don't really have very much exciting stuff going on there, do we? Nothing that impressive. And then let's look at D, because that's very different. So that solid that's forming, it could be one of two different things. The sodium and phosphorus are detaching from each other, and then they're hanging out with the elements here. So you must have an aluminum phosphate forming, and then sodium chloride, good old table salt. For row 2, I'm going to use 1 molar concentrated calcium chloride as my first reactant. I'm going to maintain the same second reactant. We'll see if we have any of the same patterns. Maybe yes, maybe no, but make sure you've got those scientist eyes open. Something's happening immediately with that column. So box C, we got to keep an eye on that one. One I gotta be careful with, sodium hydroxide. Oops, one extra drop. And then my sodium phosphate. Ooh, that's like magic. Okay, record your data. What do you see happening? Think logically about which ions are newly attached to each other. This time we've got our friend, good old copper sulfate. You might remember this chemical from the copper cycle lab that we did in lessons 7 and 8. And if not, here it comes again. Copper sulfate, so beautiful, nice light turquoise blue. Let's see what this has going on. Match that up. Add the sodium carbonate. Add sodium chloride. Kind of turn clear. Add sodium hydroxide, which was also involved in the copper cycle lab. And then our sodium phosphate. Our last row of the first sheet is 0.1 molar iron chloride. You might know a little bit about iron. People say, I'm pumping iron. Iron is found in your hemoglobin and your red blood cells. It's really good at attracting oxygen, so you can deliver that to your cells. Iron is found in pretty strong concentrations in acid mine drainage. It's one of the things that we are impacted by in this tri-state area, since we had a lot of mining happening in the 1940s through 70s. Adding the same exact ingredients we previously used, of course, following the pattern. Pretty easy peasy, just making sure I'm putting them in the right places. Giving a little bit of time for them to react, being a bit careful. Trying to keep the shadows off of there. Record. Cleanup for this isn't really that bad. I take a dry paper towel, I lay it on top until it absorbs most of the liquids. And then I carefully dispose of that paper towel and then wash my hands with soap because I don't want that to irritate my skin. And then I need to make sure that I clean this off rather than just soaking up the liquid. For my second laminated sheet, I have new ingredients on the left-hand side. We've got lead nitrate, potassium iodide, and silver nitrate. The procedure is the same. Now let's add the second reactants. Go straight down the column for convenience. Ooh, got some immediate changes there. What? Okay, record your data.